sort of. Yes. Who's orange? Miss Hodge said that her guy said. All right, Sydney, what are you defining a ratio as? It's the word rational number. Did you know rational number comes from ratio? It's true. Did anybody write more than this? A comparison of two quantities using division? Is that what you said? So jumping to the bottom, what is an example of a ratio? Is there any other way to write a ratio besides 32 over 50? Oh yeah, maybe we should think about all the ways we could write ratios. So we could write it, I'm going to use actual letters here. We could write it x over y. That's the same as if you did x colon y, which is read x to y. Any other ways we can write a ratio? Right, with the word, right? So we could say x to y. You still read it as a to b. Yeah, so all three of these are ways of writing ratios, and we're going to talk in a little bit about why would one way be preferred over another, or is there one way that's preferred over another, or does it depend on the situation? We use ratios all the time in math because we write fractions all the time in math. And so, you know, it's not something a new concept, but it's something that we just want to make sure that we're aware of, that those all three mean the same thing. So, who can tell me what extended ratio is? Did you get that far? Garrett? So a ratio compares two quantities. An extended ratio compares three or more quantities. So can you give me an example of an extended ratio? Yeah, so like 3, you could do the colon 3 to 4 to 5, or 3 to 4 to 5. Kind of weird to write that with division, right? 3 over 4 over 5, that's kind of weird. Yeah, I think to me extended ratio is dumb. If you look at we can do the ratio of a triangle, right? Like remember when you're like, I thought geometry was all about shapes. The guys are like, I want all the shapes to go away. It never makes you happy. It really doesn't. No matter what I do, I don't make you happy. Okay, so I put some examples on here. There's only one page of notes, but as you can see, I kind of squished a lot of examples on here. And so one thing we can talk about ratios is we can talk about word problems of you finding the ratio or solving for something else. So it says the number of students that participate in, I should say, right? In sports programs at Central High School is 520. The total number of students in the school is 1,850. Find the athlete to student ratio. Which way would you choose to write your answer? Support your reasoning. Which means I don't know if there's a wrong or right way to write your answer. But step one, think for a second about how you would write the athlete to student ratio. In David versus high school basketball game, fight broke out, and all the games and the IHSAA, like they don't want no basketball. both fighting the things they're out. They can't. And they're on probation for all people. Apparently it was a really rough game, like there were lots of hard fouls, and they said the refs called everything that they should have, that was supposed to do what they could, but obviously like you make the pass on something, so I don't agree with what they do, I don't know, but they like broke out on the court, and then like I saw the video, so that it was just tons of people. I couldn't really see it. Oh, I don't know, but it's not down something. I remember hearing a football game. Yeah, it's pretty crazy stuff. Grace, what did you write? Two ones up here. Colon. Students, two athletes, so that has to go first. Did anybody write it as a fraction? Do you think that we should simplify this ratio? I think we should, right? So when it says find the ratio, we should reduce that ratio if we can, either way you do it. So definitely, like, we can cross the zeros out, right? And then if you don't know, your calculator reduces fractions for you. You can just hit 52 fraction button 185. I don't know that it reduces anymore. Nope, it doesn't. Which means 52 to 185, or 52 over 185, or 52 to 185 would all be acceptable answers. Does anybody prefer one way over the other? Kinsey? Because? You're used to fractions? Like you can see the comparison more. And I don't, like I said, I'm not saying one is better than the other. The book's going to use different ones, and all three are acceptable. I just like to think about, like, do we like one better than the other? I do agree, like, thinking of it this way, you probably think of the comparison more. Fractions we are probably more familiar with. Why does it make sense to reduce it? Besides the fact that it's math class and we like reducing things. Yeah, like, and I know this one we only cut some zeros out here, but being able to say there are 52 athletes to 185 total students, like the smaller the numbers, usually the easier we're able to compare those, and so that's why you want to take the big numbers and reduce them if you can. All right, so that's really not geometry related, but then look at number 2. In triangle EFG, the ratio of the measures of the angles are 5 to 12 to 13. So there's an extended ratio here. And the perimeter is 90 centimeters. Find the measures of the angles. So take a second and think about that. Maybe you can look in your book if you want to see if there's an example like that. Talk to the person next to you. And see if you can think about a way to start this. Or maybe you already know the answer to this. And see if you can figure out Alright, I feel like we've digressed already. Back to the triangle. Anybody have a suggestion of what we could do? Yes? So how would I do that? Because, right, what does that mean, the ratio equal 280? Because I agree that, that's something to think about there. How does that affect that? Yeah, I think we definitely have to start with the angles. Like, I think we have to, like, separate this of, we need to figure out how this can help us find the angles. Could we do that? So, what does that mean, 5 to 12 to 13? Does that mean this is 5 degrees, 12 degrees, and 13 degrees? Could it mean, theoretically, pretend that this doesn't, it's more than 180, so don't, I'm breaking balls right now. But could it mean 50 to 120 to 130? Would that be the same ratio as that? Or like I could multiply each of them by 2, that's the same as 10 to 24 to 26, right? It just means like when you reduce it, that's the comparison. But we don't know like what the measure of each angle is. So what if I called one angle 5x? Could I do that? So like if I called this 5x degrees, could I say this is 12x degrees? And this is 13x degrees? And so then, playing off what Audrey said, could I use that, knowing that they add up to 180? So I can't just say 5 plus 12 plus 13 equals 180, but I could say 5x plus 12x plus 13x. And I could solve that for x and actually figure out what the interval. Does the perimeter have anything to do with things? I don't think so. So 20, is that 30x? What's the matter? No. So find the actual measures of the angles. Can I just plug 6 back in there now? Could you have just keep guessing different numbers for x until you got it? You could have, but I think this makes more sense. But now I can say that that would be 30 degrees. You can guess if it doesn't say that, right? And that does simplify down to a ratio of 5 to 13. So, what about this? Perimeter is 90 centimeters. If they asked us to find if they gave us the ratio of the side, we would have to know that it's that's something that we didn't need this point. That's one of those unneeded information. Okay. Again, I'm not giving you tons of examples today, but I'm not making them work. The other thing, whenever we talk about ratios, and we take the next step and make equations, so look a minute on the next page to look there and look at those words: proportion, means, extremes, cross product. Probably as soon as you look at it, like your mind's there at the detail back to algebra, they're like, oh yeah, I remember this. Maybe. Next slide. You agree it's kind of hard to define them using them extremes. You remember doing cross multiplying? So, does it matter? Something that I think is really important to talk about. When you set up your own problem, especially a story problem, as long as you have A and D across from each other and B and C across from each other, do you agree that you could write the same proportion in a lot of ways and you'd still get the same cross product? Like, is B over A this equal to B over C? And I solve that, would I get the same equation? Yes? How else could we write that? Could we write, even weirder, B over D equals C over A? No. B, C, and AB. That, as long as you have the things coordinated a certain way, and we're going to see this as we go into the geometry part of it, and it's the bottom of page 469. There's a little box here they talk about that these are all equivalent. It says all proportions are equivalent because you get the same cross product as long as they balance. So yes, they call those means and extremes. As long as you have the right ones multiplied by each other, it really doesn't matter whether you call them as long as the products are B and C. So give an example. I think this is just going to be my example here for you to figure this out. So the part that's going to make you super happy today is the 3 on your next page where you're just solving little problems. And then the harder part's going to be this whole problem where you have to let your own person and just apply that idea to the statistics data there. So if you haven't already started there on these problems, do your cross product, right? Set them equal to each other. Solve for X or Z. Remember that we like exact answers over decimals. We like our answers as ratios, which means that fractions are our friends, right? I like fractions. If you don't know how to get fractions on your calculator, you should see me and I will teach you. Right? Like instead of dividing, you do the fraction button. So like on this one, you get -6. all, you can just simplify that fraction, right? So before we use our calculator, let's just use our brains if we didn't have a calculator. What number goes into both 44 and 6? 2, right? So you could divide by 2 there, and you would get 22 over negative 2. That's a lovely math answer. In elementary school, they teach you to write the ethnic number, something that's just in advanced math, in improper fractions, if it's wrong, that's how we like it. So if you can give an answer like that, that's the answer I prefer. I don't want to repeat decimal. I really don't want to make numbers. But on your calculator, first of all, your calculator doesn't let negative, so you need to just disregard the negative on that and know your answer is negative. And the fraction button is on my calculator, second column, third one down. It's the ABC button. A, B, C. So instead of using the division sign, put the negative in there, or if you want to put the negative, put it on the top. You're going to have to divide by negative. You can get 44 fraction or 6. And it tells you it's 7 1/3, which is true. 22 over 3 is 7 1/3. What's even super great is your calculator. First of all, do you remember back from elementary school how to go from this to that? You take 7 times 3 and you add the top number. But your calculator will do that for you too. If you take 7 1/3 and you hit second and you hit the fraction button again, I hit second, fraction button, enter. But again, you don't even have to have a calculator to do that. You just divide by 6 and then simplify that. This would be where, again, showing you something kind of important in case you miss something, especially, right? Because it's easy to mess up here. If you distribute as you go, I'm okay with that, right? Like some of you are going to know that's times 6, so instead of showing it, you might just say 44x is 30. All day, right? Maybe 2, so you can maybe 2 on it. And you can see I kind of made each one a little bit more difficult. Where the first one you didn't have to distribute. The second one you had to distribute and solve a little bit. The third one, we have z's in both denominators. We're going to just distribute and solve that. Get our z's on one side, or z's on the other side. Good algebra practice here. So make sure you're distributing that 7 to both things and that 9. So I'm going to say 7z plus 28 equals 9z minus 9. So if I subtract my 7z over, I would get 2z. I add my 9. I get 37. So again, 37 halves is a great answer. So I feel like you guys have been like brainwashed to always get the decimal. I have to brainwash you. You give me a decimal there, that's okay. So here's the difference. 37 halves as a decimal is a terminating decimal, right? 0.5. Negative 22 thirds is a repeating decimal. And although, yes, you can write it with the repeating bar, no one uses repeating bars outside of math. I hate when people use repeating bars in math. Because it's ridiculous for math. So that's why a fraction answer. Questions about those? Alright, what about this? Monica randomly surveyed 30 students from her class and found that 18 had a dog or a cat for a pet. If there are 870 students in Monica's school, predict the total number of students with a dog or a cat. This is what people do all the time in real life things. Have you ever seen on the news? On the news, like you poll people or It's on the news all the time. So what we want to do is I think we need to set up a ratio. Agree with that? I mean a proportion. So 18 over 30 would be the ratio of 18 out of 30 people. So 18 is the number that had a pet, that was a dog or a cat, and 30 was the total number. And so then you said x over 870, because we're trying to find how many in the total school has a dog or a cat out of the total number. So you just want to make sure your numbers match up, just like we talked about with that little chart. There's other ways to set this up, but you could do 18 over x equals 30 over 870. You have those, but I agree, this is how I would set that too. But just know there's like 4 different things that are equivalent when you're setting these up, as long as you have the means and the extremes go together there. You have a question on setting that up? So once you set it up right, it's just solving it. Nice. We should do a survey of the school. So when you solve that, 522. If you would have solved that and you got a decimal, you would just round, right? Like you wouldn't say 522.7 people. Right. So yes, it's 0.5. You can, right? It's just yes. Alan. I'm okay. My whole thing was terminating decimals, it's okay. Right? Like if you want to write that as 18 and a half or 18.5, right? I'm just saying repeating decimals, we really want to get in the habit of writing those fractions. You had a question. Because 18, so you found the ratio 18 over 30, right? And then, so you just did this as a decimal, right? And then you multiplied 870 over. So do you see why that's the same thing? Like you did the exact same math that we did. You just did the ratio as a decimal, and then you multiplied by 870. Okay? Alright, so what I did is I made a worksheet for you. I have a goal for myself. I don't know if you guys are my test here. I'm giving you more worthwhile homework. So instead of giving you like 15 to 20 same problems over and over again, my goal is to give you smaller amounts of homework, but better problems. You get five. So let's look at this really quick. On the front side here, these are very similar to the questions that we just done in our examples. And there's examples in your books. So 1, 2, and 3, they are solving for things like find the measure of the angles or whatever the size. And then 4, 5, or 6 are those portions. Then on the back is where it gets where we're going to raise the bar a little bit. On the back, they give you this growth chart and they tell you information, and they ask you to use that to predict values. You're going to set up some proportion to do that, all right? And then depending on how you see the chart, you might work a little bit easier. But notice on the back there are three shadings on that chart. You don't, you probably don't know this. Every kid, you take them to the doctor, they tell you what percentile they're in. And like 5th to the 25th percentile is the light color that's kind of hard to see. So that's like underweight. If you're under the 5th percentile, then like they do the special sort of worry about that. And then the middle one, the 25th to 75th percentile, that's the most football. And then you have the 75th to 95th percentile. And then like my child, who's like giant tall, he's always been above the 95th percentile. Yeah, 95th percentile, and then his doctor also. We talk about how that kind of works out. So you of like how this is tomorrow. So try this. We'll talk about something tomorrow. Feel free to talk about it together tomorrow. Or like today if you want when you're not it and we'll go okay? But the front side you should be good.